Okay guys, so this is the windmill. um yep, let me give you a overall videos about how it's looking. Yep, that's it. This is the windmill. It's kind of big actually. The blades in here is made of steel. It's a steel blade, and the blades are connected to a DC motor in there, as you can see. Yep, right there is a DC motor. DC motor using alligator clipper. You can solder them, but I use alligator clipper to connect to a DC current sensor right inside here. There you can see the green, tiny green parts in there. I prefer to hide all the part. So the DC current sensor is sitting right in there, and then the DC current sensor is connected to the Arduino Nano right here. Yep, so that is the upper part as we have seen in the schematic file I showed you before. The motor, the blades connect to the motor, then the motor connect to the DC current sensor. DC current sensor connect to Arduino Nano to read the currents that is generated from the windmill. So whenever this starts spinning like this, the current sensor gonna read the value that is currently generating. Yep. So and then the Arduino Nano will be connected to this Raspberry Pi right here. This is a Raspberry Pi with a groove hat. So it's gonna be connected by a serial communication, which means it's gonna be a USB cable that's go all around inside the body of the windmill, and then they're gonna exit through this tiny hole down there. That's it. That's where it's it. And then the wires come plug into the Raspberry Pi. So the Raspberry Pi has this groove hat in order to use the groove potentiometers right here, because generally I can only find the potentiometer in a groove version of the potentiometers, but you surely can go with a normal version of it. So this is the potentiometer sensor, and it is connected to the Raspberry Pi through a groove hat. And this potentiometer is right here. It's got like, I make this this, I don't know what to call this, but I make this like from cardon board, and it is used to detect the wind direction, which means the wind's gonna blow straight at them, and if they blow in different direction, then it's gonna spin toward different direction. Yeah, it's just like that. And then yep, you can see this a potential, this actually a level that's inside here, but I use tape and cotton board, so it can't be seen from here. But yeah, that's how's it inside. And with a groove cable is going to connect to a groove hat of the Raspberry Pi. And then in here I have jumper wires connect to the servo. As you can see, there's a servo hidden right here. This is an MG996R servo, which gonna control the body of the windmills up here. Yep, so this is the windmill, and these are the jumper that's control the the servo, and they just again go inside the body of the windmill. You can see the tiny holes right there. I prefer to make all the jumpers and the cables hidden, so there's a tiny hole in there. Yeah, there, that's where all the wires goes in. They goes in here, and then they connect to the servo right here. And then this, I have another extra jumper wires here to connect the fan. The fan's gonna be right there. That is the fan running to, in order to cool the Raspberry Pi down. Yep, so that's it of the design. Let's see it one more time. Rolling over. There we go. That's the top view, and just like that. Okay, and so this right here is the Node-RED. Okay, so this is what happened on the Node-RED. Well, it's actually really complicated. If I go through every nodes of the Node-RED, it's gonna be really long. So I'm gonna go through what is the result of this Node-RED. So this Node-RED generate the dashboard like this here. This is the dashboard that is generated from Node-RED. So basically we have the servo motor angle, which is right here, reads the current angle of the servo. And then we have this, the servo motor rotation history, where it's gonna capture the servo motor rotation history. And then we have the currents that is generated from the windmill. And then finally, we can have the windmill run into auto rotation mode or a manual rotation mode. We can turn that on and off, and when we turn it off, then this bar right here is visible and it's draggable, which means it's interactive. If you turn it on, then the bar is going to be blurred out there like that. Okay, so this is the Node-RED dashboard that is generated from all the nodes in here. Well, let's briefly go through it. So we have, this is the switch to switch between the auto mode or the manual mode, and then the switch gonna run like a different file inside the local file of the Raspberry Pi. Say if I open the script right here. So this script right here, it's run the file auto rotation mode.py. I have shown you that file before. So when the auto rotation switch is clicks on, then that file is gonna execute. Otherwise, if it's on, then the auto file gonna execute. Otherwise, if it is off, the switch right here tell whether it's on or off. If it's off, then it's gonna go into manual mode. And yeah, and then in manual mode, we're gonna make a slider visible. Here is the slider, and then we gotta build a command for the slider. So the slider gonna generate values from 0 to 180, and we're gonna build a command to set that value to the script in the manual mode. The script that I've showed you before, the script gonna take one argument. We feed that argument into the script to make the windmill spin to our desired direction. Yeah, the rest are just and I'm show you this MQTT connection right here. This is the topic that I subscribe to. It's called it's an Hive MQ MQTT broker, and this is a topic that I subscribe to. Windmill 1 angle. This is one topic. There's another topic is this windmill 1 current. So there are two topics that I subscribe to, and get this running. So currently this is running, and it's running on auto rotation mode, which mean let's have it in demo, which mean this right here, say the wind is blowing from this direction, making this spin toward that way. But if I adjust it to spin over here, you're gonna see later, there you go. So the windmill will slowly spin toward my direction, because the wind has just blown it over there. And as you can see on the servo motor angle, it has changed in here. It has changed that the value is currently 112, and the history of the servo also shows a difference, and the rest remain the same. So I'm gonna do it once again. I'm gonna change it right here, so let you see the interactive gauge gonna change right up there. Change it up to about there, and this thing is spinning, and there you see it's currently at 62 degrees, and there's also a drop in this chart right here. Again, if I change it to in the middle, it's gonna spin toward the middle, and 94, it's not actually in the middle, it's just somewhere in the middle. So yeah, we're gonna get the history, the line graph history of where the servo motor rotation, and yep, like that. And here I'm gonna show you the MQTT server. the MQTT broker. So here you can see I am currently opening my MQTT broker, and this right here is what currently happening in the MQTT broker. You can see the two value that is continuously being published on the broker is the windmill 1 current and windmill 1 slash angles. So that are the two values that I have told you before in the node-RED. We have currents and angles, they are continuously going to be published to the MQTT broker whenever the windmill is in action. Yep, they are working, and this is their values. This is the currents and the angles. Yes, so that's what's going on with the MQTT broker. And now we're gonna try to switch to manual mode, which means we're gonna turn off this auto rotation mode, and we're gonna spin them with this thing there. So look at this. So if I decide to spin it a bit like here, there, you see I'm dragging the cursor in the dashboard right here. I'm dragging it, and as you can see, the windmill change its direction accordingly. There you go. And also the values gonna be updated into this line chart right here. It's look kind of messy because we've been changing it a lot, but in reality it won't be like that. And yeah, that's how the windmills function. And also this is the particle argons running wirelessly, running on external batteries like we have talked before. And currently it is showing, oh, it's kind of hard to see. I don't know if you can see it, but it is showing the current windmill. This one right here, I named it windmill 1, and it's showing the current, which is the power that the windmill is generating at the moment. The power that it's generating is negative 0.07 amperes, because it's not moving at all. So yeah, nothing changed. Yeah, this thing's running completely on external batteries. It's retrieve data from the MQTT server, retrieve data, and then display the data to this tiny LCD right here. Yep. And yep, I guess that's it. Thank you for listening. It's kind of a long video, and but I believe I've made it clear as much as I can. Thank you.